Again, my name is Michael Isensee. I work for the State Department of Agriculture in the Dairy Nutrient Management Program. I've worked up here in Whatcom County just over 3 years. And I'm going to talk today about our relatively recent addition to some grant funding of expanding our mission through doing some water quality monitoring to help identify pollution sources and move toward correcting those issues. So the mission of our program is to protect water quality from dairy nutrient discharges and to help maintain a healthy agricultural business climate. As a little background, we work throughout the state. We have 4 inspectors around the state. I'm, I guess, fortunate in that I'm based here just in Whatcom County, where there's about a quarter of the state's dairies. In terms of our program, we do routine inspections about every 18 to 24 months. We visit each dairy in the state. As a routine matter of business, we're looking at how they're diverting fresh water from manured areas and then how they are collecting, containing, transferring, storing, and ultimately making agronomic applications of those nutrients to their fields or exporting those to other farmers to use on their crops. So it's both keeping fresh water away from their manure, then using their manure beneficially as a nutrient source is the goal of the project. We also do investigations when there's complaints or with our monitoring if we think we've identified a source or a dairy issue, and some specialized kinds of inspections throughout the year. We, as a program, have fairly limited enforcement authority. We only focus on dairies, and our authority under state law is relating, other than some administrative and record keeping, so paperwork, our regulatory enforcement limitation is if there are discharges under the state law. So, like Department of Ecology, we may warn producers if we think there's reason that their practices or conditions on a site are likely to lead to a discharge, but actual enforcement happens when a discharge is identified and we have ample evidence that would stand up taking it through to a court. That's when the rubber finally meets the road, but it's fairly limited in that regard. So Bertrand Creek, we've been hearing about it all day. We have 13 milking parlors in the watershed. A few more dairies than that have fields or other facilities, heifer operations, dry cows within the watershed. And it's fairly uniform in some regards, fairly flat. Lots of the fields are fairly flat compared to some of our areas. The green on this map shows fields that are in a dairy plant. So it's a little more than half of all the farmland is associated with dairies in the watershed. In particular, I'm focusing today on Jackman Ditch, which is an upper tributary into Bertrand Creek. It's outlined there in orange. It's nearly all dairy land with a few minor exceptions. There is some increased rural residential development there. Karen talked about that first thing this morning in one portion. It also, like the watershed in general, half of the Jackman Ditch extends up into British Columbia. Interestingly, I noted that our Canadian partner, their map, for whatever reason, doesn't show this as part of Bertrand Watershed. It shows it in the Fish Trap or Pepin Brook watershed on their maps. So they actually don't know where it goes. And it's not her fault. That's actually how the government's maps show Jackman Ditch in Canada. So in 2014, we applied for and received some grant funds, similar funds that brought Chris and Jessica to work here in the watershed, that were to do a couple of things, but one of the things that they were to do was to give us some funding and some staff time to be looking for pollution sources, so to be sampling. Unlike Erica's sampling, we were doing, and I guess Mark talked about this too, we're chasing the storms a little bit with our sampling. I guess that tells you where we fit into the hierarchy of But we realized that fecal coliform, and as we've heard, it's mobilized with water addition. So wet conditions move it into waterways. It moves it off of whether that's in confinement areas, containment pastures. When things get saturated, it's more prone to end up in our waterways. Certainly not universally. I'll show you some of our data that shows that we get plenty of it in the summer times, but the flows are much less. So the loading is much less if there's a lot less flow. But it's not just wet conditions, but our focus was to try and better understand and identify what was happening with nutrient applications, and were there conditions or practices that were getting it into the water. And could we identify that and help operators move toward ways of managing the agronomy in terms of their timing or their rate, their equipment, their placement, about how can we get that so it's not getting into our water but staying where the farmers want it, feeding their crops, and ultimately, in our case, their cows for milk production. So here in Jackman, we have a number of sites where we sample routinely. We don't sample these every time we sample, but these are sort of our set stations that help us to identify trends between them. So it ends, this is our lowest one at the Jackman Bridge, then it heads right over into Bertrand Creek. We sample at 3 different places up at the border. There's actually more than that where there's water coming across the border, but those are the 3 primary ones. The one that's labeled border west up here is more ephemeral. It's not flowing now, and for at least half the year isn't flowing. The other 2 have perennial flow in them, maybe not this year, but at least in recent years there is flow in, especially at the border east. It has very high groundwater. The water level at the border there is fairly constant through the year. So let's see if there's anything I missed so far.
What are the blue lines?
Blue lines here are the ditch network in the farm field. So we're looking at area of about 1,500 acres here with a well ditch network for primarily drainage ditches and moving water through tile drains or for field runoff, but to drain those fields so they're farmable. So here's the 3 stations, west, main, and east, up at the border through our sampling period. It goes from oldest data here at the bottom to newest up at the top as a get you organized. And I drew a green line where we entered 2015. So we've been sampling, just about 1.5 years now. And again, it's not ambient. It's not really designed to identify specific long-term trends because we're trying to hit rain events. So we're not hitting all the conditions. We did last summer do a couple of samples in the summer. This was the area that was wet, and we got counts that were above the standards. What we have here in terms of coloration, just as a simple way of looking at things, green numbers are fecal coliform counts below 100, so they're within the fecal coliform standard. Yellow is between 100 and 200. Technically, that's within the standard for any individual sample event. You have to have a long-term geomean of 10 or more samples to be looking at what's the long-term average that needs to meet 100. Our sample data can't be used that way, but we do look at that in terms of, is it between 100 and 200? The red sites are those that exceed any single event water quality sample. So we can see that we have plenty of events that exceed the water quality standard coming in at the border. We thought it was important to sample up there for our producers to understand what they're not responsible for. And we have limited capacity to solve this problem, but we can at least identify it. We are passing it on to our partners north of the border and to state and federal regulators that are in communication with those partners. So we hope that that might lead to some changes up there. Just as an interesting point, we had a lot of really poor water quality for the first 9 months of sampling. And and I guess as a general trend, it looks better overall. Interestingly, we had more rain events so far this year that we've sampled in, even though it's a dry year. So we're becoming better storm chasers, maybe, I don't know. It's difficult to chase storms. Friday, Saturday, and Sunday last year, 2/3 of all the major rain events were on a Friday, Saturday, or Sunday. That doesn't benefit you getting your samples into the lab, and so. And I did note, more recently, all of the partners locally have been trying to coordinate some sampling. So a little less storm chasing. These are sample events that are happening the day before sampling downstream in Portage Bay. So that's to try and create some big data set that we can start looking at. Is there any trends, or can we make any more sense about that? So those ones here are identified with this, the blue dot on the right side. And then I wanted to give, this is also in Jackman, and it's 2 sites not far apart, but an upstream, downstream. Last summer and fall, we saw a pretty clear problem, which becomes most apparent when you look at the difference upstream to downstream, that in this short distance, we are seeing a pretty dramatic increase in fecal coliform counts with fairly continuously. Before that, we had plenty of high counts, but there wasn't a trend one way or the other. It was often high above and high downstream, but in this case, it was possibly high downstream, but substantially, or high upstream, but substantially higher downstream. Without taking enforcement action or actually any kind of formal action, but communicating with this producer. I know this producer worked with our conservation district. They self-corrected. They figured out some things on site that they made changes to, and we think that it's corrected. We'll see, I guess, as we move through the summer and fall, and we have a data set in the same time period, if that's true or if there's some seasonal differences, but that's what we're trying to get to. So equally important for us is, collecting the data, but also getting it into the hands of producers. They're the folks that are on the ground that can actually do something. I can collect data, I can regulate, but unless we have producers who care and have information to act on, things won't change. So that's really, for us, where the rubber is meeting the road with our information. We're trying to get it. We get sample results from a lab 24 hours later. We try and get it out then, that same day, to producers who've asked for it, even though it's preliminary, because we know that by the time we get final results in 3 or 5 days, they will have moved on. They won't be thinking about, what did I do yesterday, 3 days ago? They won't know, what did I do last week that would have caused this? So that timeliness for us is really important. So, and I'm leaving it there.